Who attended the Australian National Ballooning Championships?
Earlier, it was thinking about those hot air balloon championships that brought to mind a comment that a member made to me last month, which was, "Geez, Steve, you're so full of hot air." And set me to thinking about air, that thing that we take for granted. Now, we know that air has mass. By the way, how many people have done physics at high school? There you are. So I'm not shocking anybody. We know that air has mass, and when air moves, it can either ruffle the hair on your head or lift a 640-ton Antonov 225 into the air. And air can destroy a building if the wind is blowing hard enough. So I want you to think of this. Did you know that in Australia, our average home is the largest home of any country in the world? I don't see anyone shocked, so they must be thinking, so what? Well, the average home in Australia is 241 square metres, and there will be a theme here. You'll get it as we go along. Our home is larger, for instance, in the US it's 201 square metres, Italy 81, Russia 57, barely enough for a toilet in an Australian home, isn't it? Canada 181 square metres. So this average Australian home with its area has a volume of 550 cubic metres, and here's where the physics comes in. Standard temperature and pressure. Each cubic metre of air weighs 1.292 kilos, so just over the weight of a box of Wheaties. So the air in this average home will have a mass of 710 kilo. Impressed yet? No. Now, let's think in terms of the balloons that we saw up there. The average balloon carrying 3 to 5 people has a capacity of 2,800 cubic metres, which is 5 times the volume of our average house, and the mass of air within the balloon is 3,618 kilo. However, if we heat this air with a flame and the air reaches a temperature of 99 degrees, the mass of air in that balloon now is 2,656 kilo. So the molecules of air have gained energy because of the heat. They move about more vigorously, need more space to move, and therefore the air becomes less dense. Now, the displacement difference is 962 kilo in that balloon, giving nearly a tonne of lifting force. That's how they rise. But back in 212 BC, Archimedes recognised that a buoyancy occurs equal to the weight of space, so he was already on the game. But coming back to our average home, let's see what happens when a cyclone approaches. On average, a cyclone causes a drop in air pressure of 15%. So the mass of air in the home is now heavier than the air outside, but only by a factor of about 100 kilos. So that's not going to blow out the windows, doors and lift the roof, is it? So imagine you leaning against, or me, not perhaps you, but me leaning against the door, that's the force involved. However, when those cyclonic winds of 160 kilometres an hour go over the roof ridge of this theoretical 241 square metre home, according to Bernoulli's principle, whoever remember that one, the air pressure above the roof decreases just as in an aircraft airfoil, giving a lifting force of 31 tonnes. Now we can see some things happening here, can't we? That is 31 balloons, hot air balloons, tethered to one house's roof. Perhaps that's why they tend to blow off in cyclones. The Antonov's 225 wing area is 905 square metres, just 4 times larger than that roof. So when that Old Fliers group member said, "Steve, you're full of hot air," I thank him for the gift of that idea for the talk.